Okay, hello all. We're going to have a look at chapter 5 in the Pearson's Year 2 book. The topic is radians. We're going to break it up into 3 chapters. The first chapter, the first video, is going to be about, well, simply what is a radian, how to convert between degrees and radians, and how to solve simple radians equations, or simple equations where we're using radians as the measure of angle. So therein lies the clue. A radian is a measure of turn. It's an angle measure. Now we're used to using degrees, and randomly there are 360 of those in a circle. A radian has a specific definition. I've got a circle. If I draw a radius here, it doesn't matter what the radius is, let's call it r. If I measure a length around the circumference, that's also a length r, let's say approximately there. So there are 2 radiuses. This length is also r. This is the angle at the center. Then this angle is 1 radian. 1 radian. So this is the definition of a radian. It's the angle subtended at the center of a circle when the length of the arc is equal to 1 radius. So this length is the same as that length. That's what a radian is. It means in a circle there are 2 pi radians all the way around. So 2 pi radians is the same as 360 degrees. In other words, 1 radian is 360 over 2 pi degrees, or more commonly 180 over pi. So 180 over pi is your multiplier in order to be able to work out radians to degrees, and obviously degrees to radians. You'll be dividing by this. So for example, if you wanted to work out what 2.3 radians is, it's 2.3 times by 180 degrees over pi. 2.3 times by 180 divided by pi equals 131.78 degrees. So that's how you convert from radians to degrees. First example. Second example, converting from degrees to radians. So let's say 165 degrees. We're going to do 165 divided by 180 over pi, which you can obviously also write as times by pi over 180. So this is how many radians. So 165 degrees, 165 times by pi divided by 180 is, so my calculator has given it as 11 over 12 pi. You often find with radians, you're not writing down your answer as a decimal, but you're writing it down in terms of pi. So how many radians are in a full circle? 2 pi. Half a circle, pi. 90 degrees, half pi. So you have pi over 3, pi over 6. In this case, 11 over 12 pi. If you don't like that, you can write it down as a decimal, usually to 2 or 3 decimal places. So that's what a radian is. This is how you convert between radians and degrees. There's a few standard ones you need to know. So 2 pi radians is equivalent to 360 degrees. So pi radians is 180 degrees. Pi over 2 radians is 90 degrees. Other common ones are pi over 3 is 60 degrees, pi over 6 is 30 degrees, and obviously then you've got the multiples of these. So for example, 5 pi over 6 is 5 lots of this, which is 150 degrees. And the way you use these are exactly the same as each other. You can put either in your calculator. Make sure your calculator is set to radians rather than degrees if you're going to be using radians. But you'll see I'm often referring to radians in terms of how many pi's. That's pi, by the way, not PIE. So these are standard ones you need to know. Good to remember them. Better put my units in and get used to what they are. So on your cast diagram or ACTS, that's naught. This is pi over 2. This is pi. This is 3 pi over 2, and full circle is 2 pi radians. So this would be pi over 4. Let's add that to our list. Pi over 4 is 45 degrees. Pi over 4, this is 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. Worth knowing these, knowing where they are on your ACTS, on your cast diagram, and also how they convert to degrees. Worth spending some time playing around with this, and the first exercise tests you on a lot of these, helps you practice these things. Okay, so that's what radians are. The next video we'll be looking at arc length, area of a sector and area of a segment using radians. The formulae are much easier than for degrees.